So now that we've had a chance to talk about the structure and the functionality of condition objects at a high level, let's zoom in and talk about specific methods that it defines. So the key methods, not surprisingly, are used to allow threads to wait and notify each other. And there are three key methods. There's some overloading on one of them, but we'll focus on the three of them. They are await, signal, and signal all. Now, ironically, these names are similar but not identical to the wait, notify, and notify all methods that are defined on Java's built-in monitor objects. And that's a little bit confusing, and I'll talk more about just how confusing it can be later. You might ask the question, why did they go to the trouble of having different names if they do more or less the same thing? Well, the most obvious reason, there's several reasons, but the most obvious reason is that the wait, notify, and notify all methods that are part of the Java object class are defined as final and can't be overridden. So they had to give new names, right? They had no choice because they couldn't override them and extend them. This does actually cause some confusion, though. And I've seen people do some weird things, and you very well may run into some bugs when you program stuff because of this. Internally, these methods are implemented by the abstract queued synchronizer framework, as are many other things in Java util concurrent. Await is very straightforward. It suspends the calling thread until it's signaled or until it's interrupted. What happens when you call await is the thread parks itself on the condition object's wait queue. And it also atomically releases the lock. So that's the other thing it does. Signal takes whoever's been waiting the longest and moves it to the queue for the owning lock. So remember, there's somebody who owns the lock, who owns the entrance queue. Remember, there's always a lock associated with a condition object. And when you do signal, it takes one thread, whoever's been waiting the longest, and puts it on the queue for the owning lock. In contrast, signal all takes all the threads and put them on the owning lock's queue. So this will take one thread, let's say this is that person there. So this takes that person and puts them here, whereas signal all puts them all on the owning lock's queue. The problem with this is in many situations, this will lead to something called the thundering herd problem. So the thundering herd problem is sort of a whimsical analogy that says, there's a thundering herd descending on this one poor lock queue. And this becomes particularly problematic if only one of those threads actually gets a chance to do anything. So remember the pizza analogy we talked about the other day? If there's a pizza that shows up and there's the keys for the truck, the way I described the scenario was all the sleeping delivery people wake up, and they all go running out to try to grab the pizza, grab the key. Only one of them are going to get it, and everybody else woke up from their nice, relaxing nap for nothing. Right? You're probably better off just waking up one person. So that's the thundering herd problem. Having said that, there are situations where calling signal all makes a lot of sense, especially if there's multiple resources that could be obtained, much like the semaphore example we talked about before. There are some other methods in condition object. We've looked at await. That's the one we just looked at. There's also 4 other ones. There's one that's a timed await. There's one that lets you wait with nanosecond resolution as opposed to microsecond resolution, or time unit resolution, which could be a millisecond, microsecond, a second, and so on. There's await uninterruptibly, which says just wait till the cows come home, right? Till the thundering herd shows up. It says don't let me be interrupted by an interrupt. Kind of a dangerous thing to use in some ways. And then there's also await until, which is waits until a deadline. So those are the other 4 await-related methods. Interestingly enough, this is yet another reason why Java's built-in monitor objects absolutely suck. They have Java built-in monitor objects have timed wait calls, but they don't return a value to indicate whether they timed out or not. So they're practically useless in practice, or they are effectively useless in practice, as you can read about here if you're curious. In contrast, the await call here that's timed gives a value that's a return value, whereas the ones that are built into Java, built-in monitor objects have just a void return type, which means they don't return anything. And so this way you can distinguish between something that timed out versus something that actually got the resource it was waiting for. Okay, so that's just a quick overview of some of the key class methods. You will get a chance to program with many of these in the next assignment.